In deep water fields where a floating unit is required, there are 3 types installed in the Gulf of Mexico: SPARs, TLPs, and semi-submersibles without production storage. The FPSO concept, based on ship-shaped vessels, is being used in several locations all over the world, but its motions are sensitive to weight height, and so far there is no one operating with SCRs, steel catenary risers. By changing the weight distribution and using certain hull appliances and special shape ratio, a much better notion response is reached, making the operation of flexible risers very comfortable to stress and fatigue. The production flow could be done by flexible risers or SCRs, steel catenary risers. Flexible risers have several internal layers to provide high flexibility, but they were still not approved to operate in ultra-deep water and under very high fluid pressure. In this case, the SCRs come up as one of the best solutions, but they cannot support excessive motions imposed by the platform. To overcome these problems, Petrobras sought a solution by designing a new FPSO to operate straightly with the steel catenary risers. So here comes the concept of the Mono-BR. Petrobras R&D Center, CEMPES, and Petrobras America have developed the Mono-BR conceptual design to operate with SCRs in water depth of 2,500 meters in the central area of the Gulf of Mexico. The production plant capacity is to treat 120,000 barrels of liquid per day and to produce 100,000 barrels of oil. The unit's storage capacity is of 800,000 barrels of oil to be exported through offloading operations. The flow system will count with 6 production risers and 1 gas export pipeline, also receiving the production from another platform from 1 import oil pipeline. Titanium stress joints were considered to connect the risers to the hull. The platform has a cylindrical hull with decreasing diameters from bottom to top to reach the best hydrodynamic characteristics. Additionally, the Mono-BR shape provides excellent deck area and deck load capacity. The main draft of 39.5 meters provides the best motion responses in very rough seas. Nevertheless, in case of mild environments, the platform can operate in drafts varying from 28 to 47.5 meters. A great deal of attention was paid to motion analysis due to its influence on the risers, mooring, and topside design. Numerical analysis and model tests indicated good motion responses even in the harsh environmental conditions of the Gulf of Mexico. With this configuration, in order to reduce angular motion, the principle of increasing the added mass of the hull was used. This effect was reached through the external hydrodynamic shape of the hull, using a beach combined with a skirt. These shapes also dampened the unit's motion under the effect of waves. To reduce vertical motion, the same principle was used, but through a moon pool tank inside the hull structure. The moon pool has its height, diameter, and bottom opening designed to counterbalance the inflow and outflow water period in the moon pool with the wave period. VIM motions were studied, as well as their impact on riser design. The amplitudes and periods are such that risers' fatigue damages are not significant. The 13-line mooring system, composed by chain and polyester segments, was designed for extreme weather conditions and fatigue. The mooring pattern could be arranged to meet the best seabed layout, minimizing the riser's lengths. The mooring lines are pre-tensioned by means of chain jacks and pass through swiveling fair leads with chain stoppers. This system is easy to operate, demands little maintenance, and allows the required tension adjustments. Numerical simulations of the hydrodynamic behavior of the platform, combined with the structural dynamics of lines and risers, were performed using the numerical offshore tank. Simulations were carried out for a broad range of environment combination, including Ivan and Katrina hurricanes. Improved stability is one of the main characteristics of the system, which exceeds the requirements of classification societies. The high stability reserve positively contributes to a low-risk operation, both in intact and damaged conditions. The unit has 8 cargo tanks served by 1 submerged pump for each tank. A portable submerged tank provides redundancy in the case of failure of a dedicated pump. All oil tanks are surrounded by a total of 24 ballast tanks that compose the double hull. Of these, 16 are external ballast tanks and 8 are internal. The internal tanks separate oil tanks to minimize the emptying of these tanks in the case of inspection. The ballast system uses 4 submerged pumps to reach the main draft in a maximum of 4 hours of ballasting operations. The Mono-BR tolerates more severe damages than what is conventionally required, and it is able to compensate associated heel, restoring the even keel position only by means of ballasting operations. The Mono-BR can also go to a repair draft 10 meters below the main operational draft, thus facilitating the repair services.